Let me take a couple minutes to explain left-handed limit and right-handed limit. You can also call this left side limit or right side limit. We have a piecewise function f of x equals to x plus phi if x is less than 0, function equals to 2 when x is equal to 0, and then we have a parabola if x is greater than 0. So let's sketch the graph really quick. So we have a linear function when x is less than 0 and the slope is equals to 1, so the function is going up. So when x is equals to 0, we have 0 plus phi, right? So y is equals to 0. When you sketch the graph, be very careful. There is no equal underneath the less than. So when x is equals to 0, 0 plus phi y is equals to phi. So the 0 phi, that is an open circle. So this, when x is 0, y is equals to phi. This is an open circle. Do not use a solid circle because there is no equal underneath the less than. And then we sketch the line. So this is the first piece, x plus phi, and then when x is equals to 0, y is equals to 2. So x is equals to 0, y is equals to 2. Let's do a red circle for this. So when x is equals to 0, y is equals to 2. So that is equals to 2. This is a solid circle because x is equal to 0. So when x is equals to 0, y is equals to 2. This is a solid point. And then we have a parabola opens down because we have a negative in front of the x squared plus phi. So that is a parabola opens down, and then we shift the vertex 5 units up. And then the last piece looks like this. So that's the parabola. Now, let's do some limit. So how about this? Let's check the left limit and right limit of 0. So how about this? We are trying to check when x approaches to 0 from the left and x approaches to 0 from the right. So what is x approaches to 0 from the left side mean? So look at my cursor. So this is 0, right? And then this is your left hand side. So when x approaches to 0 from the left, what does that mean? That means x is less than 0. So that means x is less than 0. And then on the other side, when x approaches to 0 from the right, that means x is greater than 0. All right, so limit as x approaches to 0 from the left of f of x, what is that equal to? That is limit as x approaches to 0 from the left. We are taking the first piece, the linear function x plus phi. So all you have to do is you plug in 0, 0 plus phi is equal to phi. What about the right side limit? The right limit as x approaches to 0 from the right, or you call this the right-handed limit, f of x. So this is limit as x approaches to 0 from the right. So on the right hand side, we have a parabola, x approaches to 0 from the right. So this time we use the quadratic function x squared plus phi, and then you plug in the 0, you have 0 squared plus phi, that is equal to phi. So after the job is done, we see that the left side limit is equals to phi, the right side limit is equals to phi. So therefore, we say that limit as x approaches to 0 from either side of f of x, the limit is equal to phi. All right. The left side equals to phi, the right side is equals to phi. As a result, the limit is equal to phi because the left side and the right side, they have the same result. Now, what if the right hand side is not equal to phi? So let's say, for example, the left hand side is equals to phi, the right hand side is equals to 10 or 4 or negative 10, not phi. What do we say? If so, we should write this down. So that is equals to phi. So just a what if, all right? Just a what if. So what if the limit as x approaches to 0 from the right, just a what if, of f of x, that is equals to 12. What happened if that is equals to 12? If that is equals to 12, that means when x is coming to 0 from the left hand side, y stops at phi. When x comes to 0 from the right hand side, y stops at 12. That means those two functions, they are broken into two pieces. They stop at two different destinations. As a result, the limit as x approaches to 0 from either side of f of x does not exist. Okay, so when you check the left limit and the right limit, if they equal to the same value, then the limit exists. If they are not equal to the same value, then the limit does not exist. Okay, and then what else can we say? So one other thing that we can say is, we can say f of 0 that is equals to 2 when x is equals to 0, y is equals to 2. Now, answer a question for me. Is the function continuous at x equals to 2? So is the function continuous at x equals to 2? Oh, sorry, not x equals to 2, sorry. At x equals to 0. The answer is no. Why? For informally speaking, can you draw these two pieces? Look at my cursor right over here. Can you draw these two pieces without picking up your pencil? The answer is no. When or where did you pick up your pencil when you draw these two pieces? Don't worry about the dot. When you draw these two pieces, where did you pick up your pencil? You pick up your pencil at the open circle when x is equals to 0. That means the function is not continuous when x equals to 0. So the function is not continuous. I should say f is not continuous. F is not continuous at x equals to 0 because 0, 5 is an open circle. But how do you make this function continuous if you change the function a little bit? So allow me to do this. So if you do this, so I'm going to copy this and then paste that over here. So if I make a change, all right, so let's use a different color to make a change. If I make a change, all right, I take this away and then I said when f of x is equals to 5, if x is equals to 0. Or let me just do it right here because I want to change the graph to so that is equals to 5 if x is equals to 0. How do we change the graph? So let's bring the graph down. So I am going to take this, copy, and then paste. How do we change the graph? To change the graph, first of all, I need to erase the red dot, right? I need to erase the red dot because when x is equals to 0, y is equals to 5. This is a solid dot. That means this dot is solid. What happens when this dot is solid? Then you can sketch the entire piece without picking up your pencil. Then at this time, f is continuous at x equals to 0. Alright, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, click the subscribe button. If you're on your way out, I will catch you all in the next one. Signing off for now.